Hello students, I am Sachitrakar. Welcome to Cars Physics. In today's lecture, we will discuss projectile thrown or fired from a height. Okay, projectile thrown from a height means we may throw a body, we may project a body from the top of a building or from top of a tower. Okay, so there are three cases to be discussed. The first case, a projectile thrown from a height or a body thrown from a height with a velocity u parallel to surface of earth. Okay, this is surface of earth or ground and velocity is parallel to surface of earth. Means here velocity of the projectile making an angle 0 degree with horizontal. Okay, then second case, a body is projected from a height is h, but making an angle theta with horizontal. See, this velocity is parallel to horizontal and this velocity means this u makes an angle theta with horizontal. Okay, this is projected from a height, this body is also projected from a height, but here velocity is parallel to horizontal, here velocity is making an angle theta with horizontal. Okay, so here the body is thrown making an angle theta with horizontal in upward direction. So this is third case. Here also a body thrown from a height h with a velocity u making an angle theta with horizontal, here angle theta, here also angle theta. But here the body is projected upward and here the body is projected in downward direction. Okay, so there are three cases in today's class. So let's go to basic basic discussion first, then we'll have some simple and easier numericals on the basis of these three cases. Okay, it's fine? Thanks. Okay, the first case, we'll have fundamental from this first case, then we'll apply to the next two cases. Okay, so here a body is thrown with a velocity u from a height h, and here velocity u is parallel to horizontal or parallel to surface of earth. Okay, like the body is thrown when time is 0 and we may take coordinates here 0, 0. See, in previous lecture, means in lecture 1 on projectile we have discussed. Projectile motion is here in this subject we are discussing two-dimensional motion, means motion on a plane. When a body moves on a plane, then two coordinates change. Suppose here we are taking, this is y-axis and this is x-axis. Okay, so when the body is thrown, coordinates are 0, 0, means x is 0, y is 0. When the body reaches at this position, see, this is x coordinate x1 and this is y coordinate y1. So coordinates are x1, y1, means when the body moves to a new position, then the coordinates are changing along x-axis and along y-axis. Similarly, when the body reaches at this point, the coordinates may be x2, y2. So this distance is x2 and this total distance means this much height the body is dropped is y2 and so on. So This is motion on a plane means x coordinate is changing and y coordinate is also changing. Okay. Then what is the nature of motion? We'll go to detail. Okay. Suppose this is a height h from which the body is thrown in horizontal direction with a velocity u. Okay. So obviously you know, if you throw a body like this, means parallel to surface of earth, it will move in a curved path. So as we have observed, the body moves in a curved path. Okay. So here coordinates are 0, 0 and time is 0. Okay. Let at any instant the body has reached at point P when time is t and coordinates are 0, 0. Sorry, coordinates are x and y. Means to reach at point P, the body has covered a distance x along x axis and a distance y along y axis. This is also y axis. Okay. So coordinates of the point are x, y. But what is the nature of motion? You just see the concept. The body is thrown in horizontal direction with velocity. So what is? So u is velocity given to the body in horizontal direction. Then what is the initial velocity in vertical direction means along y axis? 0. As we have discussed in just previous lecture, a vector has no component. A vector has no component at an angle 90 degree to its direction. A vector has no component at an angle 90 degree to its direction. We have discussed in just previous lecture. So again, I would like to advise the students who have not gone through projectile motion, lecture 1. This is lecture 2. Projectile motion, lecture 1. Once go through it. I have discussed all basic discussions, means fundamentals on projectile motion. Okay. See. So a vector has no component in perpendicular direction to itself. So velocity given in horizontal direction. So initial vertical direction initial velocity in vertical direction is 0, since this is direction of velocity and this is vertical direction and angle is 90 degree. So this component will be u cos 90 cos theta, that's equals to 0. Similar, acceleration due to gravity acts in vertically downward direction. See, if this is acceleration due to gravity in vertically downward direction, then acceleration due to gravity has no component in horizontal direction. Means there is no force is acting either along the direction of horizontal velocity or opposite to the direction of horizontal velocity. Since acceleration due to gravity has no component, if acceleration is 0 in horizontal direction, then force is 0, since force is product of mass and acceleration. So no force is acting along the direction of velocity or opposite to the direction of velocity, and acceleration due to gravity is 0 in horizontal direction. Then what will happen? If velocity is constant, if acceleration is 0, then velocity is constant. Because if a velocity changes, then acceleration is produced. Okay. If acceleration is 0, it means there is no change in velocity. So this velocity will remain constant. So horizontal velocity remains constant throughout the journey. But in vertical direction, see, suppose I am holding a body. The body is at rest and the body is now released. When the body released, then the body has initial velocity in vertical direction is 0. Okay. So a body is released from rest. So initial vertical velocity is 0. Let's release the body. And when it strikes on the ground or when it strikes on my hand, then it strikes with a velocity. Means velocity increases in vertically downward direction due to effect of gravity. Then what conclusion do you get? Here, the body moves under combined effect of constant horizontal velocity and increasing velocity. And increasing velocity means magnitude of velocity increases. Increasing velocity in vertically downward direction. This is the output of our discussion. If a body is thrown from a height with a velocity in horizontal direction, then velocity along horizontal direction remains constant since there is no component of acceleration due to gravity in horizontal direction. So horizontal velocity remains constant. But along vertical, initial vertical velocity is 0, but there is gravity acting on the body, means body is accelerated in vertically downward direction. So velocity in vertically downward direction increases. Okay. This is our output. In this case, the body moves under combined effect of constant horizontal velocity, and though initial velocity in vertical direction is 0, vertical velocity in downward direction increases due to effect of gravity. Okay. Is it clear? Is it clear to all? Okay. Now I reading this part. Then first we will get. This is the path followed by the projectile, and as we have discussed in just previous lecture, the path followed by projectile. The path followed by a projectile is called as trajectory. Path followed by a projectile is called as trajectory, and we are going to get what is nature of trajectory in this case. Nature of trajectory means what name we can give to this curved path. Okay, what name we can give this curved path. Okay, let at any instant of time t, the body is at P and coordinates of point P are xy. Time taken is t. So time taken by the body is t to cover horizontal distance x and to cover vertical distance y, because coordinates of point P are xy. So time taken to cover distance x is equal to time taken to cover distance y. So horizontal displacement or horizontal distance covered by the body is x, but in horizontal direction velocity is constant. Just apply one equation. S is equal to ut plus half at square. Now considering horizontal displacement x, in place of s we can write x u. Velocity along horizontal direction is u and time taken by the body is t, ut plus half acceleration. See, in previous lecture we have discussed x direction and y direction. In x direction, velocity ux is u, which remains constant. In y direction, initial velocity is uy, that is equals to 0. In x direction, acceleration is 0. Acceleration due to gravity has no component along horizontal. Acceleration is 0, and along y direction acceleration is g. This is positive because motion is in downward direction. Okay, so plus half acceleration along x-axis or along x direction is ax into t square. So x is equal to ut plus half acceleration is 0 into t square, means x is equal to ut. Time taken by the body to reach at point B is xy u. Then now considering vertical motion, this is horizontal motion, x is displacement. Now considering vertical motion, to reach at point P, vertical displacement is y. Then apply same equation. In place of s, we do take y, u. In vertical direction, initial velocity is 0, ut is 0 plus half acceleration in y direction into t square. So y is equal to half acceleration in y direction is g. T square means t is equal to x by u, so x square by u square. So y is equal to g by 2u square into x square. Is it clear? Then g is constant, acceleration due to gravity at a given place is constant, and u is constant, so g by u, 2u square is constant. So I may write y is equal to a constant into x square. So this is the equation of parabola. Thus, we may name this curved path parabola, and nature of trajectory. Nature of trajectory is parabolic. This curve is named as parabola, and nature of trajectory is parabolic. Okay. Then we will go to different points. Okay. Can I erase it now? Fine. Okay. See. The body is projected when time is 0, and here the body strikes the surface. Let time is t. Then our first heading, as we have discussed, similar form in previous lecture, time of flight. Time of flight t. From time 0 to t, time taken is t to reach the ground. So what is time of flight? The time during which the body flies. Means time of flight is time during which the body remains in space. Body is released at t is equal to 0. Not released from rest, but it is thrown horizontally with velocity u. Okay. So from 0 to time t, when time is t, the body strikes on the ground. So for this time t, the body flies, but it remains in space. So t is time of flight. Time of flight. Now considering vertical motion, consider vertical motion, and use the equation AC is equal to ut plus half at square. See, in time t, the body is thrown from the top of a tower. Let height of the tower is h. Projectile from a height. Let height is h. You may take this is a building or a tower. So when time is t strikes on the ground, then vertical displacement is h. In this time, vertical displacement is h. Okay. Then in place of s, we can write h. In downward direction, vertical displacement in downward direction, and in downward direction, initial velocity u is 0, ut is 0, plus half acceleration in y direction into time is t square. So h is equal to half acceleration is g into t square. So t, time of flight, is square root of 2h by g. Okay. Then when the body reaches reaches on the ground, then time is t. So in this time, the body has covered a vertical displacement h and horizontal displacement r. Then what is r? We have discussed in previous lecture. R is horizontal range. Means maximum horizontal distance covered by the body in time of flight. Horizontal range is maximum horizontal distance covered by the body during time of flight. Okay. So maximum horizontal distance is range. Okay. But in horizontal direction, velocity is constant. In horizontal direction, acceleration is 0. Again apply the same equation. Horizontal displacement is r, u. Horizontal velocity is ux, means u. Total time is t plus half. Acceleration along x-axis or x direction is 0 into t square. So range is equal to ut. So range is equal to u. In place of complete total time, we may write 2h by g. This is formula for range and this is formula for time of flight. Okay, then the final point. Then the final point on this part, instantaneous velocity. Instantaneous velocity. So instantaneous velocity, as we have discussed in previous lecture, instantaneous velocity is velocity at any instant of time. Velocity at any instant of time is called as instantaneous velocity. Let the body reach that point P when instantaneous time is t. At instantaneous time t, the body reaches that P, okay, and continues its motion. So velocity at any instant of time is instantaneous velocity. Then we have to get the expression for instantaneous velocity when the body is at P. The body is moving in a curved path, and as we know, if a body moves in a curved path, if a particle or if a body moves in a curved path, then direction of velocity at any instant, direction of velocity at any position can be determined by drawing a tangent at the required position. If a particle or if a body moves in a curved path, then direction of instantaneous velocity is determined by drawing a tangent at the required position. See, body is moving down, so at this point, this is the tangent. This represents instantaneous velocity. This is direction of instantaneous velocity. See, this velocity is inclined. This velocity is not directed either in horizontal direction or in vertical direction. So this velocity will have two rectangular components. Along x-axis, component is Vx. Along y-axis, component is Vy. Component is Vy. This is V. This is Vx, this is Vy, and angle between them is 90 degree, means Vx and Vy are rectangular component. Let this velocity, instantaneous velocity, makes an angle alpha with x-axis. Okay. Then Vx, magnitude of horizontal component of velocity. As we have discussed, horizontal velocity means velocity in x direction always remains constant. See, body is thrown with a velocity u. Here initial velocity is 0. Okay. When body reaches at this point, again horizontal velocity is u, but velocity is increased in vertical direction due to effect of gravity. So when the body reaches at this point, velocity is u in x direction, and velocity again we increased, left velocity is v. Okay. So horizontal component always remains constant. Okay. Then instantaneous velocity, velocity in x direction, vx always remains constant, that's equals to u. And in vector form you may write vx vector is equal to u into I cap. Because u is directed along positive x-axis as per our convention, thus vx is equal to u. And direction is along positive x-axis, we do take unit vector I cap. And vy is vertical velocity, as we have discussed. In y direction there is acceleration, but in y direction initial velocity is 0. So using the equation v is equal to u plus 8. Okay. And time taken by the body to reach at p is t, and vy final velocity vy when time is t, initial velocity u means 0, u is 0 plus a acceleration along y axis v1, then acceleration is g and time is t. Okay. Thus in vector form we may write gt, direction along negative y axis. This is y axis and this is x axis. So direction is along negative y axis, so we may take minus j cap. So in vector form we may write instantaneous velocity is vx plus vy, or you may write it u I cap plus gt into minus j cap. Okay. Then what is magnitude of instantaneous velocity? As we have discussed, angle between vx and vy is 90 degrees. So rectangular components are vx and vy. So obviously magnitude of instantaneous velocity is square root of vx square plus vy square plus 2 vx vy cos 90. Okay. Then magnitude of instantaneous velocity vx square u square, vy square, magnitude of vy is gt means g square t square. Then about direction, let instantaneous velocity makes an angle alpha with x axis, then tan alpha, which will show us a direction tan alpha, simply taking perpendicular upon base. Vy is perpendicular, length of this line represents magnitude of vy, this length is also same, this straight line also represents magnitude of vy, and this angle is 90, perpendicular upon base vy by bx. So tan alpha vy, magnitude of vy is gt, magnitude of vx is u, then direction alpha is equal to tan inverse gt by u. So this is all about a body projected or thrown from a height in horizontal direction. In horizontal direction. Okay. So let's have some numericals starting from basic to application numerical. On the basis of this discussion, then we will go to other cases. Okay. Can I erase it? Okay. Have this formula in mind and the concept also, not only formula, the concept also. Okay. I have some questions. This is my collection questions, easier questions, and you may ask me your doubt questions. Question number 1. Question number 1. A projectile is fired horizontally with a velocity of 98 meter per second from the top of a tower 490 meter high. I am showing you in diagram. Height of this tower is given, h is 490 meter. 490 meter. Okay. A body is thrown horizontally with a velocity u. Velocity of horizontal velocity is 98 meter per second from the top of a tower 490 meter high. then obviously the body will travel in a parabolic path. Okay. Then what to find BT? It is asked the time taken by the projectile to reach the ground. Just apply the formula. Time applied is t. Here t is 0. Then t is equal to square root of 2h by g. H is given g. You may take g 9.8 meter per second square. Now you may calculate and the answer will be 10 seconds. 490 divided by 9.8, you calculate 10 seconds. Then B bit. It is asked the distance of the projectile, distance of the point where the projectile hits the ground. Okay. Distance. This is the distance on the ground. Means we have to find this distance, means we have to calculate range of projectile. Then formula for range is u into t, then u root of 2h by g, then u is 98 meter per second, root of 2h by g is 10, then this is 980 meter, then bit c, 980 meter bit c. The velocity with which the projectile hits the ground. Okay. Velocity with which the projectile hits the ground. See, the projectile comes and hits the ground like this when time is t. So, to get with what velocity it hits the ground, draw a tangent. This is velocity of striking, and again this velocity will have two rectangular components, Vx and Vy. And this angle is alpha. Then we have to get instantaneous velocity. The form is instantaneous velocity. Here the velocity is final velocity with which it strikes the ground. Then, as we know, horizontal component of velocity Vx always remains constant, and in vector form it is ui, as we have discussed, and Vy. Final velocity in vertical direction, time taken is t, and initial velocity in vertical direction is 0 and acceleration is g. Then final velocity Vy is equal to u plus 80 means gt. Then in vector form Vy is equal to gt into minus j cap, and in vector form you may write final velocity is equal to Vx plus Vy. And v is equal to ui cap. Initial velocity is ui cap plus gt into minus j cap, and you may write this u is 98 meter, 98 I cap plus g is 9.8, and time applied to you got 10 into minus j cap. So final velocity is 98 I cap plus 98 minus j cap. Okay. Then magnitude we may calculate square root of 98 square plus 98 square, and that's equals to 98 root 2 meter per second, and direction tan alpha is equal to Vy by Vx, and tan alpha is equal to Vy is 98, Vx is 98, this is 1, so alpha is 45 degree. Okay. These are the answers, so the basic, just apply the formula. Then we will have some good questions, good numericals also. Question number 2. A bomb is released. This is also a common question. I have taken it. A bomb is released from a helicopter. A bomb is released from a helicopter. Okay. The same diagram will help us. A bomb is released from a aeroplane. A bomb is released from an aeroplane flying horizontal with a speed. Aeroplane is flying with horizontal speed of 200 meter per second. Okay. 8,000 meter above the ground means height above which aeroplane flies is 8,000 meters. Find horizontal distance of bomb when it strikes the ground. Okay. So, this is an aeroplane. This is an aeroplane. Okay. This is flying in horizontal direction and releases a bomb. Then obviously the bomb will move horizontal as that of velocity of aeroplane. Okay, velocity of aeroplane is u and bomb will also move with velocity u because it is released from the aeroplane and the aeroplane is in motion. The bomb will have same motion when it is released. Thereafter, there will be effect of gravity on the bomb and it will move in a parabolic path and strike on the ground. Then what is distance covered by the bomb? Distance means range. Directly asked to calculate the range. Okay. So it may be asked in different ways. A helicopter releases a bomb just above the target. Will it hit the target? No. See, if it releases the body from this point, it will not move in vertically downward direction. Suppose here there is target. The bomb will not move in in vertical direction directly to hit the target. It will move horizontally because the helicopter is in motion. Then what is distance missed by the bomb? Same distance r because it hits at this point. Similarly, different types of question are there, but concept is same. Okay. A helicopter releases food packet to Jawans or in flood affected area. Okay. Just above the people were standing. So the people can't catch because the food packet will move in a parabolic path. There are two effects, velocity in horizontal direction and acceleration due to gravity in vertically downward direction. So what is distance? Range. As you have discussed, ut, then range is equal to u root of 2h by. Then range means distance traveled, horizontal distance traveled by the bomb. U is 200, root of 2 into 8,000 divided by 10, 0, 0. So range is equal to 200 square root of 1600. Then range is equal to 200 into 40. Then this is 8,000 meter. 8,000 meter. Too much. Okay. So two easier questions. Then question number 3. Question number 3. Oh, this is a beautiful question. Okay. A ball, I am writing because options are given. A ball rolls up. A ball rolls up a stairway with a horizontal velocity. With a horizontal velocity u. With a horizontal velocity u, meter per second, u meter per second. If the steps are h meter high, if the steps are h meter high and b meter wide, h meter high and b meter wide, the ball will hit the edge of m step. The ball will hit the edge of nth step if the first option n is equal to hu square divided by 2gb square, second option n is equal to hu by gb, third option n is equal to 2hu square divided by gb square, 2hu square divided by gb square, and fourth option is 2hu divided by g square. Pause the video and try it once. Pause the video and try it once. Okay? 5. These are the stairway, and this is nth step. This is nth step. Each stairway is b meter wide and h meter high. See. Okay. If the steps are h meter high, this is h, this is b, this is h, this is b, and n number of steps are there. Okay. So h meter high and b meter wide, the ball will hit the edge of nth step. The ball will hit the edge of nth step. If n is, what will be the choice? See, this is the total height from which the ball rolls up. The ball rolls up horizontal with velocity u, and this is the total horizontal distance traveled by the ball. Then total height is equal to obviously nh, because height of each step is h and there are n number of steps. So total height is nh and horizontal distance r. Width of each step is b. B up to n means range is n. Is it clear? Then what you know? Range is equal to u root of 2h by g. Then range is nb, u root of 2, height is nh divided by g. Then square both sides. N square b square is equal to u square into 2nh by g. Then n cancels square. Then n is equal to 2h u square 2h u square divided by g, and cross multiply b square gb square. This is your answer. Then which option? Option C. 2h u square divided by gb square. Good question. Then another question on the basis of this theory, and this is a very, very good question. Not good question, not very good question, very, very good question. Okay. Can I erase this? Okay. Yes. Okay, this is a good question. I have only diagram, and this is question number 4. So this is the tower. This is a tower. Two bodies are projected from height of a tower. Two bodies are projected from the height, from the top of a tower in horizontal direction but in opposite direction. Question is like this. This body is given a velocity u1, this is 3 meter per second, and this body is given a velocity u2, this is 4 meter per second. Okay. So I am writing the question. Question number 4. Two bodies are projected, very good question, from the top of a tower also find distance between the bodies when their velocities are perpendicular to each other. No doubtly, this is a question for competitive based or application based question. Two bodies are projected from the top of a tower are shown in figure. Means a body is projected in horizontal direction with velocity u1 3 meter per second, and another body is projected with velocity 4 meter per second. This is along positive x-axis direction and this is along negative x-axis direction. Negative x-axis direction. Then we have to find distance between the bodies. Distance between the bodies when their velocities are perpendicular to each other. Very good question. Just think and try it. Just think and try it. Good question. No doubtly good question. Okay. This body must pause the video. And try it once. See, this projectile will move in a parabolic path. This projectile will also move in a parabolic path. Let when the bodies are fired, then instantaneous time is 0. The two bodies are projected in opposite directions in horizontal direction at same time. Okay. Let when this body is A, this body is B. When A reaches at this point and B reaches at this point, their velocities become perpendicular to each other. Then velocity of body is along the tangent. This is horizontal component, this is vertical component, and velocity of B is along the tangent V2. This is horizontal component and this is vertical component. And as we have discussed, horizontal velocity is u1, direction is I cap. So initial vertical velocity is 0, initial vertical velocity is 0. Then this is v1 x, which is equal to u1 I cap. Then this is v1 in y direction, then v1 in y direction is equal to u 0. Acceleration along y direction is g, u plus at, acceleration is g. Let time taken by the body to reach at this point is t, and this is also taking same time to reach at this point, because both bodies are projected at the same time. So v1y is equal to gt. So v1 vector is equal to v1x vector plus v1y vector. So v1 is equal to u1 I cap, this is u1, plus v1 is gt into minus g cap. This is along negative y direction. Okay. Then similarly here, this is v2x, this remains constant, this is u2, but direction is along negative x-axis, and this is v2y. This is also gt, u is 0, 0 plus gt, this is gt, and along negative y direction. So v2 vector I am writing directly u2 minus I cap plus gt minus j cap. So v2 is equal to, okay, this much, v2 is this much, but it is asked what is distance between the bodies. when their velocities are perpendicular to each other. When their velocities are perpendicular to each other, this is a concept of vector. Condition of perpendicularity. Under what condition two vectors are perpendicular? We know. Result of dot product. A vector dot B vector is equal to AB cos theta. AB cos theta. If angle between A vector and B vector is 90 degree, then A dot B is equal to A cos 90 means 0. This is the condition of perpendicularity. What's the condition? If dot product of two vectors is 0, if dot product of two vectors is 0, then the vectors are perpendicular to each other. Then here, let's assume V1 and V2 are perpendicular to each other, then dot product of V1 and V2 is 0. Because it is asked to find distance between the bodies when their velocities are perpendicular. Let's consider their velocities are perpendicular when the bodies are reached at the respective points A and B. You may take this is A dash and this is B dash. Okay. Then expression for V1, I am writing directly U1 I cap minus GT J cap. GT minus J cap minus GT J cap dot. V2 is minus U2 I cap minus GT J cap is equal to 0. We have assumed the velocity are perpendicular to each other, then their dot product is 0. Then just multiply U1 I cap minus U2 I cap minus U1 U2. I cap dot I cap is 1. Then U1 I cap dot GT J cap is 0. I dot J is 0. Then minus GT J cap minus U2 I cap. So GT U2 minus into minus is plus. Okay. Sorry, this is 0. J dot I 0. J dot I 0. So this is 0. Then minus GT J cap minus GT J cap. J cap dot J cap is 1. Minus GT means minus G square T square. Minus into minus plus G square T square is equal to 0. Minus into minus is plus GT into GT G square T square. Okay. Then G square T square is equal to U1 into U2. Then T is equal to root of, you may take like this, T square is equal to U1 U2 by G. I am doing here, so T is equal to root of, sorry, this is G square, root of U1 U2 by G. Square root of G square is G, square root of U1 U2. So time is root of U1 is 3, U2 is 4, 3 into 4 divided by G means root 12 by G second. Let the body A has covered a distance x1 to reach at this point, and body B has covered a distance x2 to reach at this point. Then total distance, we have to find total distance between the bodies. Total distance, let x is equal to x1 plus x2, and as we have discussed, the horizontal velocity remains constant. Means acceleration along x direction is 0. So x is equal to x1. x1 is equal to u1 into t, and x2 is equal to u2 into t, ut plus half at square. Acceleration is 0 along x-axis, acceleration is 0 also along negative x-axis. So ut plus half at square is 0. So this is u1t plus u2t. So total distance is u1 plus u2 into t. So x is equal to u1 plus u2, 3 plus 4 into t. Time is root 12 by g. So total distance is 7 root 12 by g meter. You may put value of G also 9.8 for final calculation. I have left taking G. The last question on the basis of projectile thrown horizontally from a height. Is it clear? Good question. Take it. Must take it. Okay. Applicable for competitive, not for board base. This question is competitive based question, not for board. Okay. Last question on this theory. A stone is thrown horizontally from the top of a tower, hits the ground at a distance 18 meters from the foot of tower. I am showing you on the basis of diagram. Okay. This is the last question. This is a tower. And it is given height of tower is h 24 meter. Okay. A stone is thrown horizontally. This is a stone thrown horizontally from the top of a tower, 24 meter high, hits the ground. Let velocity of projection is u. Hits the ground at this point at a distance of 18 meter, at a distance of 18 meter from the foot of tower. This is 18 meters. Then what is asked? We have to calculate, find velocity of projection. U is asked. You can solve it. See, the range is equal to 18 meter, height is equal to 24 meter. Okay. Then U is asked. Just apply the formula. R is equal to U root of 2h by g. Put value of h, put value of g, put value of r, and solve for u. You can do it. No need to do. Okay. And I think I have taken this much of question on the basis of projectile thrown in horizontal direction from the top of a tower. Then other two type of projectile, only let's approach numerical. Okay. A body is thrown from a height of 40 meter. On the basis of question, a body is thrown from a height of 40 meter with a speed of 20 meter per second, with a speed of 20 meter per second at an angle 30 degree with horizon. Okay. Then different points may be asked. Whatever we may be asked, I am not taking. I am discussing with you. So what are the possibilities of asking? See. A body is thrown from a height. Let's take this is a tower. This is height of the tower. H is equal to 40 meter, height of tower. A body is thrown from the height of 40 meter with a speed 20 meter per second at an angle 30 degree with horizontal. This is horizontal direction. Okay. The body is thrown like this. Let velocity of projection is u. U is 20 meter per second. And theta is 30 degree. The body moves in a parabolic path. Okay. Body moves in a parabolic path like this. If the body were thrown from the ground itself, then the body would strike on the ground, moving in a parabolic path. But here, it is projected from a height, so body will go on moving and finally strike on the ground at this point. So this is horizontal distance covered on the ground. We may say also this is range on the ground. Okay. Then what may be asked? It may be asked to find time of flight. See, the body is thrown when time is 0 and the body strikes the ground when time is t. Then we have to calculate time of flight t. See, this velocity u, this is theta. So horizontal component is u cos theta and vertical component is u sin theta. And we know acceleration due to gravity in vertically downward direction. Here you have to take sign convention. Initial direction is taken as positive in general. I have discussed from very beginning of kinematics. Initial direction is taken as positive. C. Considering vertical motion, considering motion in y direction. Vertical means y direction. So this is y-axis and this is x-axis. We are considering motion in y direction. So uy, this is uy. Velocity in y direction, initial velocity in y direction is u sin theta, and acceleration in y direction is minus g, because u sin theta is upward and g in downward direction. This is vertically upward, g in vertical downward direction, so g opposes u sin theta, so taken as negative. Okay. And time taken to reach the ground is t, means the body is projected from this point and strikes on the ground at this point. So vertical displacement or displacement in y direction is h, but displacement is in opposite direction to that of u sin theta. But if you consider y direction, then u sin theta along positive y-axis, but displacement along negative y-axis. So displacement is minus h. So let's use the equation AC is equal to ut plus half at square. Here displacement is minus h. In place of u, we may take uy into time is t, total time, plus half. Acceleration is ay into t square, so minus h is 40. Uy is u sin theta, u is 20, theta is 30, 20 sin 30. This is uy into t plus half. Acceleration is minus g into t square. So minus 40 is equal to 20 into 1 by 2 into t, sin 30 is 1 by 2 minus half. You may take here 10 in place of g into t square. So what we got? Minus 40 is equal to 10t. 20 by 2 is 10, 10t minus 5t square. Thus 5t square minus 10 minus 40 is equal to 0. Now this equation is in quadratic form. Solve for t. You will get t is equal to 4 seconds and 2 seconds. Then from quadratic equation, if you solve it, then t will be 4 seconds and 2 seconds. Then what is the answer? You will take the greater one, because the body directly not coming from the top of tower to ground, it moves up, then it moves up. See, u sin theta will go on decreasing due to effect of gravity, and the highest point u sin theta is 0. And here only velocity present is u cos theta. The body first goes up, then moves down. So take the greater one, 4 seconds. Okay, so time taken by the body to reach the ground or time of flight is 4 seconds. Then other questions may be asked. What is horizontal distance? Horizontal range. So maximum horizontal distance is distance covered by the body on the ground. This is also range, this much. You can calculate it taking u square sine square theta by 2g. But here I am calculating horizontal range on the ground, so x. Horizontal velocity always remains constant, so u cos theta is constant. So speed is u cos theta, time is t. Along x direction, acceleration is 0. Along y direction, acceleration is ay, that is equals to g. So s is equal to ut plus half at square, acceleration in x direction is 0. So horizontal distance is u. U is 20 cos 30 into time is 4 seconds. So horizontal distance means range is cos 30 root 3 by 2 into 4. Just calculate it. This much meter. So x is equal to 20, 10 into 4, 40 root 3 meter. You can calculate this. Okay. Horizontal range, then what may be asked? Other point, maximum height. See, suppose this height is h, then maximum height is h plus h. Height is measured from ground. This is capital H and this is small h. And h plus h, this is height, maximum height of in projectile motion. If consider body is thrown on the ground, then h, formula for h is u square sine square theta by 2g. You can calculate it now. H is given 40, u is 20, theta is 30, take g 10 meter per second. You can calculate it. Also it may be asked velocity of striking or final velocity with which it strikes on the ground. You may take here, this is velocity. This is velocity of striking. Take like this is v. Okay. Along this vx, along this vy. Okay. And with x axis, let angle is theta or alpha, whatever you may take. Strikes with a velocity v. Horizontal component is vx, vertical component is vy, and angle is alpha or theta. So vx is equal to u cos theta. See, u cos theta, horizontal component remains constant, then vy. Vertical velocity is u sin theta in upward direction, but here vy, when it strikes on the ground, vy is in downward direction. So vy is equal to u sin theta minus g. U sin theta in upward direction, g in downward direction. So now we can calculate v is equal to square root of vx square plus vy square, and tan alpha is equal to vy by vx. Vy and vx. Just use this, you can get your answer. Then last bit. See, this is the projectile projected at an angle from the top of the tower, making an angle theta with horizontal or 30 degree with horizontal in upward direction. Last one in downward direction at an angle. Okay. I am erasing this. I am writing the question again. A boy standing on the top of a tower. Boy. A boy. Okay, I am showing you by taking help of diagram. I am reading the question, you can estimate it. Okay. A boy standing on the top of a tower 36 meter high. Okay. Height of tower is given 36 meters. 36 meters. Boy standing on the top of a tower 36 meter has to throw a packet to his friend standing on the ground 48 meter horizontal. Okay. This is ground and his friend is standing at a distance of 48 meter from the foot of the tower and the boy is standing on the top of the tower. Okay. Has to throw a packet to his friend standing on the ground 48 meter away horizontally. If he throws the packet directly to his friend with a speed 10 meter per second, how short will the packet fall? Last bit I am writing. If the boy throws a packet directly to his friend with a velocity of 10 meter per second, how short will the packet fall? Will the packet fall? Okay. Boy is standing on the top of the tower, his friend is standing on the ground at a distance 48 meters from the foot of the tower. Suppose the boy throws a packet directly to his friend with a velocity, let u. Okay? Velocity is given 10 meter per second. Then it is asked how short will the packet fall? Just think, if the boy throws like this directly towards his friend, will the packet come like this? No. The packet will not move in a straight line because acceleration due to gravity. Acts in vertically downward direction, which will tend to move the body in a curved path like this. The body will fall at this point, means packet will fall at this point. Okay. Let the boy is at position A, his friend is at position B, and the packet falls at position C. Then we have to calculate this distance. How short it falls. The packet will not fall at B, but it will follow a parabolic path or curved path, will strike at C. Then this is the distance missed by the packet. So how short the packet will fall? This much distance is D. Okay, C. To calculate this distance means BC, let this angle is theta. This is straight line. So tan theta, see. This angle is a 90 degree. Perpendicular is 36, base is 48. Then tan theta is 36 divided by 48. This is equals to 3 by 4, and you know this is 3. This is 4, this angle is theta, this angle is 90, and this is 5. Okay. Tan theta is 3 by 4. Then we can get sin theta, cos theta. Using this triangle, right angle triangle, then tan theta is equal to 3 by 4. Let this vertical displacement is y, this horizontal displacement is x. Then y is equal to c. Have I gone through the question? Means angle. Okay, let's take this angle theta. Then component of this velocity in the x direction is u cos theta, and in y direction is u sin theta. And acceleration due to gravity in downward direction. See what will be nature of motion. Acceleration due to gravity has no component in horizontal direction, means x direction. So this will remain constant. x direction and y direction. In x direction, initial velocity ux, u cos theta, that will remain constant. In x direction, acceleration is 0. Since acceleration due to gravity is in vertical downward direction, there is no component of acceleration due to gravity in x direction. This is in y direction. Okay. In y direction, initial velocity is uy. This is uy. That's equals to u sin theta. In y direction, in negative y direction, of course, and acceleration in y direction is g. Both are in same direction. So initial direction is downward, g also downward. So y is equal to, see, displacement is y, initial velocity. You take this equation, s is equal to ut plus half at square. Then displacement is y, initial velocity, in place of u, we can write u sin theta. U sin theta. Time taken by the body to reach at this point, you may take small t or capital T, you may take, plus acceleration ay into, this is uy, this is ay is g, not minus g, because u sin theta and g in same direction into t square. Okay. Then what is y? Y is 36. U is 10 into sin 30. Sin 30 is 3 by 5 into t plus half. Let's take g 10 t square. Then 36 is equal to 2 into 360 plus 5t square. So 5t square plus 60 minus 36 is equal to 0. So this is your equation. You can solve it now. Okay, you can solve it now. 5 into 2, 60. 10 by 2, 5t square. Okay, you can solve it now. Solving, you will get t is equal to 2.15 second. Solving it, you will get 2.15 second. Then we will calculate what is the distance missed by the packet. What is the distance missed by the packet? See. Suppose this distance is x. Let's take this distance is x. Means the body is thrown from A and reaches at C. So this is horizontal displacement. So x is equal to horizontal velocity is u cos theta in x direction into time is t, and acceleration in x direction ax is 0. X is 0 plus half et square is 0, and x is equal to u cos theta. U is 10, cos theta is 4 by 5, time is 2.15 second, and this is 2 into 4, 8 into 2.15, 8 into 2.15. Then x is equal to 16.15 into 8. Okay, 17.2. Then distance missed is BC. The packet missed this much of distance. Then what is distance missed by the packet? Total distance is 48, and x is minus 17.2 meter. Minus 17.2 meter, then answer will be 30.8 meter. This is the distance, how short the packet will fall. Thanks, my children. This is about a projectile thrown from a height. In next lecture, we will discuss inclined projection, projected up the inclined plane, projected down the inclined plane. Thanks, my children. Thanks.